Hello everybody, Namaste, Salam and Sat Sri Akal. Sudhir here, and let's get to the navigation video for the factor analysis app. First log into zerocode learning using your given credentials and launch the factor analysis app. This is your zerocode learning site. I have logged in, and in the list of apps that are there, you will find the factor analysis app. Launch it. It should launch like this. Yeah, it should come here. Won't take long. In the meantime, there it is. It's come here. Now let me head back to this part. Examine the app layout. There are input fields, there are output tabs, 9 output tabs and 5 input controls. So these are your output tabs, 9 of them, and there are these 1, 2, 3, 4, 5 input fields, input controls. Okay. Go to the overview and example dataset tab, download the empty cars.csv dataset to your local disk in any convenient location, and then we will load the downloaded file into the app. Okay, so let's go here. In the overview tab, you see there are these 3 odd examples. Please click on this and it will download okay, so it will download it has saved in my downloads folder. I am headed there. Downloads are here. Empty cars 1. Please read it in. So this is an example file that I'm just walking you through. You can go to data and see what the data look like. So there are 32 entries, 32 rows, and 11 variables. Okay, so these variables you can see are also here. You can select a variable, you can drop it from the analysis, or you can add it back, any of these variables, any number of variables. Okay. All right, so there we are. Okay, now we will go to the summary tab, and these are the outputs that will emerge. Let's go to the summary tab. Okay. The first output that you will see is this upper triangular matrix of correlations. The 11 variables, how do they correlate with one another? You can see that a variable's correlation with itself is going to be perfect, 1.0. Its correlation with other variables will be lower. Blue means positive, darker blue means more positive. Red means negative, darker red means very negative. Okay, so you can see that. So what does this mean? The car's weight, WT is the weight of the car, versus MPG, mileage per gallon, which is your miles per gallon, mileage. The correlation is negative 0.87. Okay, so mileage and car weight are negatively correlated, which kind of makes sense, and so on. Okay, if you go below this, you will come to the test summary, factor loading summary. Okay, and below that there is the uniqueness table. I will walk you through all of these. Okay. Now the 32 by 11 original matrix. So remember the original empty cars matrix had 32 rows and 11 columns. So 32 by 11. That's how we call this. That is the original matrix size. We are splitting this matrix, factorizing this matrix into 2 factor matrices. Okay, the product of which will give us the original matrix back again, or some version of that. So let me show you here. The machine has chosen 2 as the optimal number of factors. We can change that. We will change that and see. For now, let's assume 2 is the number of factors. So the original 32 by 11 matrix is split into 32 by 2 times 2 by 11. Okay, so the 2 and 2 will drop off and you will get 32 by 11 back. Okay. All right. This 32 by 2 matrix is called the scores matrix. The 11 by 2 matrix is called the loadings matrix. Okay. So this one will be 32 by 2. There are 32 rows and 2 factors, and each of these cars, Mazda, Datsun, each of these cars, each row has a score on each factor. Okay. Suppose I change this to 3, then it will become 3. Now this becomes 32 by 3. Okay. If you make it 4, then it will become 32 by 4 and so on. Okay. All right. If you go to the loadings tab, there are 11 variables. Yeah. So there are 11 variables and 2 factors, so 11 by 2. Okay. If you change the number of factors, it will become 11 by 3, 11 by 4, and so on. Yeah. Right now, the machine has chosen 2 as the optimal number of factors. Okay. Now, this particular table, the same table, is also displayed here, factor loading summary. Okay. I'm going to use this table because it is less cluttered, yeah, and it is sorted in terms of which variables load onto which factor. So here the empty cells that you see, it doesn't mean they are 0, it's that they are close to 0, and we have eliminated them, eliminated as in hidden them for better readability. Okay. So these are 11 variables, 2 factors. So how do you interpret a factor? Factor 2, for instance, would be, low on mileage, yeah, negative loading on mileage, positive loading on engine displacement, positive loading on car weight, uh, positive loading on number of cylinders, positive loading on horsepower, positive loading on number of carburetors, positive loading on pickup. QSEC is the inverse of pickup. Yeah. So what could factor 2 be? Okay, so one has to interpret each factor in terms of the variables that load on that factor. A positive loading means in favor of the factor, a negative loading is against that factor. So in this case, factor 2 is power, okay, because horsepower is high, pickup is high, car weight is high, engine size is high, mileage is low, all of them coming through. And factor 1, if you do similarly, we will see that it is actually economy. Okay, mileage is high, car weight is low, and all of that. Okay, so you can go here and write that name down. Okay, economy and power. Okay, it is a good idea to name the factors. I mean, you can't have a space in between. You can have an underscore or something and write the names of the factors. Okay, all right. Uniqueness table. Well, let's get there first and then I will show you. The factor loading summary is what we just saw. Sorted and decluttered. Cumulative and proportional variance is also given. Now please look at this. Okay, what does it mean? When I took these 11 variables and I reduced them to 2 factors, okay, an 11-dimensional object projected into 2 dimensions, how much information did I retain? How much information did I lose? Turns out that the first factor on its own retains about 41% of the original information in the original matrix. The second factor adds a further 40%, so total 41, 40. Total, cumulatively, the 2-factor solution is able to recover 80% of the original information in the matrix. So if I kind of make this 3, you will see that it's now moved to 86%. So the 3-factor solution is recovering 86% of the original. So we are going with 2 because the machine chose the 2 as the optimal number of factors. Okay, uniqueness table lists the uniqueness value, uniqueness score. Okay, so higher the uniqueness score, okay, you can sort the uniqueness score. So this is the most unique one is carburetor, followed by DRAT, followed by vertical or straight. DRAT is a rear axle ratio apparently. VS is vertical or straight cylinders, number of gears. Higher the uniqueness value, more unique that variable is, and the less it is explained by the factor solution. Okay, so the less unique, lower the uniqueness value, the better it is explained by the factor solution. I mean, that's the interpretation of this. Okay, let's get back here. Okay, so you can see this. Higher the score, lesser is that variable's information captured in the factor solution. Now let's go to the plotting tabs. There is a tab called factors versus variables. Okay, remember we gave the factors these names: factor, economy, and power. I have written them down here. Let me go to factors versus variables. This is what it looks like. Okay, these are color coded. I think all of these are in factor 2, which is power, and all of these are in factor 1, which is economy. Okay. This is called the latent structure of the data. Color-coded intercorrelational structure of the 11 variables. Okay, so if the link between two variables is green, it means those two variables are positively correlated. If the link between them is red, they are negatively correlated. Darker the color, higher the correlation, and wider, thicker the link, higher the correlation. Okay, all right. Let's go to another graph. This is factors versus variables 2 tab. Okay, and this shows the factors as axes, and these factors are by construction perpendicular or orthogonal to each other. Okay, let's get here. All right, so what do we have? We have something like this. This horizontal axis is the economy factor, and the vertical axis is the power factor. Okay, and all these 11 variables are represented by these arrows. Okay, you can see GAIR and AM. Okay, I mean the smaller the angle between an arrow and the axis, higher the loading of that arrow variable on that factor axis. I mean that's basically. So carburetors is loading heavily onto power, whereas number of gears is loading heavily onto economy. I mean that's basically how it comes through. Okay, yeah. The arrows are the locations of the variables in 2D factor space. We have two factors, that's why two-dimensional. Smaller the angle between a variable and a factor, higher the loading of the variable on that factor. Finally, I am going to show you the third curve, which is factors versus users. Okay, folks, remember this is again the horizontal axis is economy and the vertical axis is power. If you go to the scores tab, each of the cars has a score on economy and on power. I am going to use this as my x variable coordinate and this as my y coordinate. So Mazda RX-4 is at 1 and 0.55. So 1 and 0.55, Mazda RX-4 is somewhere here, and you can see that. So these are all location coordinates taken from the factor scores. Okay, that's basically it, and you can see that we now have a neat 2 by 2. So as you can see, these axes are at the 0 level. Yeah, so it splits the entire graph into a 2 by 2. Okay, so you have on this side, the right half of the graph are those cars which are higher than average. Average would be this axis, higher than average on economy. Left half is lower than average on economy. Similarly, the top half is higher than average on power, and the bottom half is lower than average on power. Okay, so there it is. A natural segmentation can be seen. Yeah. So in some sense, we are segmenting these graphs on the basis of economy and power. I mean, that's what we're doing. Okay, this is a recent-ish addition parameter, which is basically based on parameter tests. This is based on public demand request that I got. This tab basically was added last month. 3 statistical tests that go with factor AN. The KMO test for factor adequacy, the Bartlett's test of sphericity, and the matrix determinant for factorizability. Basically, will the matrix invert or not? There is also a principal axis solution which is visualized, but again, that's not very important. So this one, effectively for each variable, we get a KMO score. Okay, and if the score is if it's greater than 0.6, then we are fine. If it's less than 0.6, then we might want to consider dropping those variables. Here all the variables are fine. I mean, they are all greater than 0.6. Test of sphericity. The observed correlation matrix, is it significantly different from an identity matrix or not? This is the p-value. Clearly, the lower the p-value, the more the confidence. This is very strongly not an identity matrix, so we are fine. We basically look for p-values which are 0.05 or less. This is pretty much 0 for all practical purposes. Finally, determinant for factorizability. This is the determinant of the matrix. As long as it is non-zero, we are okay. Okay. A zero determinant matrix cannot be inverted because it becomes infinity 1 by 0. And that's it. We've seen all of them, and this is the data tab which we saw in the beginning. Yeah. Okay.